Okay, I guess it's 5:34, 7:34 in EST, so we can get started. Happy Thursday. Hopefully you guys are doing good. And our goal for today is basically to finish Docker part. And then I was hoping that we can talk a little bit about, uh, I don't know how familiar you guys are with data engineering, how familiar you guys are with what's happening, uh, different roles that come in data. Um, so I thought it would be a good time so that you guys have a little bit more uh, view, like a broad view of what we are trying to do as data engineers, and how things are happening. So that would be the second part of the lecture. The first part of the lecture, I'm thinking I will be focusing on Docker Compose, which is the part of Docker that's left. Uh, Again, going back to the project we have, uh, why are we learning Docker? It's because Airbyte and Metabase are in Docker. Uh, does that mean that if something is in Docker, they are not in EC2 instance? No. These Docker containers are running in EC2 instance. Why do we need Docker then? It just makes our life easier because it's just so much faster uh, to do things that way. But that's just part of our project. Why do Docker gets used in the industry? Because they do not have boundaries of EC2 instance, and you can use Docker as managed services. That means cloud take care of uh, how many EC2 instances you need. You don't take care of it. You just have a container which can grow and grow and grow based on your requirements, and there's nothing that can stop it. So that's why we are using Docker or introducing Docker. It's a very highly used technology. It gets used quite a lot. So it's a good idea to understand it. But with our project, Airbyte and Metabase is what would be running in Docker. So before I go into Docker Compose, any questions? Okay, then I guess I can get started with Docker Compose.
Actually, sorry to stop you. I have a quick question.
Yeah,
I was gonna type it out, but I
yeah,
figure I'll just say it real quick.
yeah.
I know we have to install Airbyte and I believe Metabase on Docker's containers to do
Right.
the project. Can these applications also be installed on EC2 without Docker? Just like if we didn't want to
You,
use Dockers, can we just use EC2 for every single application?
I think so. So let's see. Airbyte installation. And I'm thinking they should have. So Airbyte, I can see that they just recommend Docker Compose. I don't think so. They created anything without Docker. Uh, Metabase, I feel like uh, had something going on without Docker. So Metabase installation. Let's see. So yeah, so you can go through jar file, which is, as it says, the most basic way of running it. So yeah, you can go without Docker. Uh, if your question is, should you do your project that way? You can. The only thing is that I just want to make sure that once you go out of this program, you know how to do things a little bit. Like you know how to make containers in Docker. How do they look like? Which browser should I go to to reach out to that container to work on that container? So until unless you show like those concepts are good, uh, you can go ahead and go through, like for example, for Metabase, go to the jar file and do it. It's just yeah, it's just the instructions of the program is not based on the jar file. So if you get stuck, It's just a little more Googling on your side. Otherwise, every other place, like how to install Metabase using Docker, that's all guided, and there are instructions in the learning portal for that. Hopefully that makes sense.
It does. Thank you.
No problem. Okay, let's go back to Docker Compose. So what's happening with Docker Compose? So usually what I do is, let me get my EC2 instance, uh, and let's talk about Docker Compose while doing things. Okay. Okay. So this is the problem. So I already started my EC2 instance. It's all updated and I installed Docker in it. So I don't have Docker Compose, but I do have Docker in it. Other than that, what I have done is I have a folder with Docker in it. Now, the thing that I'm trying to do is there is a database called MongoDB, which is a NoSQL database, and I guess in future in program you will talk about what NoSQL means and all that stuff. Make sure. Okay, that's good. Yeah, so you will learn about NoSQL and all that stuff. But right now, my goal is two. So I have a Docker container of MongoDB, as well as I want to interact with MongoDB, and that comes with one more container, which is called MongoDB Express. So I have basically two containers, and it's the connection of both two containers that will help me get something done. So I have to build something in which both of those containers are talking to each other, so that in the end, the result is that I have something that I can work on. So in order to do that, I have to do it through few steps. So let's write out those steps first and see how we will program it uh, for it to work. So let's say these are okay. I will just name this as Docker compose.yaml file. And the reason why I'm naming it like that is going to come in the future, but right now I'm just naming it like that. Okay, so the first thing, because I want them to talk to each other, they should be part of the same network. So that's the first thing I want to do is make them part of the same network. The second thing that I want to do is I want to start or create MongoDB container. And the second thing that I want to do is I want to create MongoDB Express container. And hopefully once I do those two things, joined by the same network, I should be able to make them talk to each other. And hopefully that should be enough for me to go ahead and get and achieve what I'm trying to achieve. So the first thing is to create this network. So how can we create this network? We know it's just Docker network. So that's one more command in Docker. Create, and let's say it's Mongo network that we are trying to create. So as I am creating it, I'm just going to run it on the terminal as well. And okay, so whenever you see this error, what you do is sudo chmod. You just give the access here. And is so if I do Docker network, so you can see that it gave me something. And if I do Docker network and I think ls, now there are a few things that you can see here. We will go a little bit into Docker networks. So there would be some explanation of what you see. But right now, what we are thinking about is at least like whatever the network I want to create is there, which is called Docker network. Sorry, Mongo network. That's perfect. Now let's think about how can we create this container. And again, all the information that I am writing here from now on is coming from, so how do you usually do it if you want to do it yourself? Usually in companies, you would have an infrastructure engineer who would give you a lot of good information about these stuff. But if you don't have anybody, you're working on a startup or something, so you just can go to Docker Hub, and then you can just go to MongoDB. And then you go to the MongoDB official image and you're like, okay, how to run it. And I think in the most simplest form, you can just do MongoDB name and dmongo tag. That's all. We will be making it a little more complicated because we will be using like root username and root password and all that stuff. So, so that's why my code would look a little bit different, but other than that, the port is going to look same, but all those pieces of information is I am grabbing basically from here. That's the main idea. Okay, let me go back to my container and I can say, okay, how to create a container. I can do Docker run, and most likely I will try to do it detached. And then the port that I'm going to work on, and that's the port that MongoDB already gave me, is 207017. And if you didn't see that port, it was just right here. That's the MongoDB standard port. Uh, Then comes environmental variables. So I'm just going to take the variables from there as well. So let's take, I guess, both of these and uh, put it right there. Okay, so it's MongoDB init -e, MongoDB init root username. And let's say that equals to, we are just going to change it for our purposes to admin. And again, you can do anything, any username or any password. I'm just changing it for my purposes. Let's say this is just password. Okay, so environmental variables are set. Uh, I will go through what YAML file is, Stella, in a little bit. So right now, I'm just what I like. I just named it like that. I could have opened a text file to do it. So right now, any purpose that I'm doing here, it can be done in any file. So yeah, so the YAML file is not important right now. It will be important in in a little bit, and then I can explain what model file is. Okay, so passwords are done. I have to tell it what network it should connect to. So we know that it's Mongo network that it should connect to. And we can give it a name. I think network is still a keyword. So net. Uh, we can give it a name as MongoDB, and then the last part is where you give it the flag. So I'm going to just use the latest image. And I think it's called Mongo. So let me just make sure the package is called Mongo. Yes. So the latest tag would be, uh, I guess it's going to decide by itself. There is no latest tag, so I guess I cannot pass the latest tag. I will just do Docker pull Mongo for right now. So it can just pull whatever is there and is regarded as latest. Okay, so that's my command. Hopefully by now you know what each part of this command mean. So I'm just going to select it and copy paste it right here. Okay, so it grabbed the latest, whatever is tag latest, and it pulls all the images as, okay, perfect. Talked about. So if I do, okay, so if I do Docker ps-a, I can see that it's up from 2 seconds. Everything looks good. Now let's go to the second part. the Express part. And again, there is something called Mongo Express. So very same idea. And I will just copy paste it because a lot of configurations are very similar. And then I can change it based on my use case. So it would be run as well. The ports are a little different because this one would be hosted. So I can go and see it, how it works. So 8081. I think its name is meconfig admin user. Let me grab it. Its image. So MongoDB Express. So that's where the image is. And let's see. So I can grab this, which is its admin password. Uh, so that is what this would be. And I'm going to give it as admin. Now, let me grab the other keyword, which is this admin password, and paste it right here. Okay, so that's that keyword. And then it should be connected to network. Name should be Mongo Express. And the image that we are looking for is Mongo Express as well. I'm just going to copy this and paste it here, and it's going to create a new container. Now, I guess when it's completed, now the main point that I want to tell you is if I, and just to show you that this container is working, so I can do docker ps-a, you can see Mongo Express is there as well. I do port forwarding, 8081, and then if I click on this, it's going to, oh, port forwarding should be ready. Let's see, it should be 8081. Status is 9 minutes. Just want to make sure that the container didn't die. Oh, it's exited. Okay, Mongo Express is exited, so I have to restart it. So let me just do docker start Mongo Express. Okay, docker ps-a. It's up for 3 seconds. It exited 8 seconds ago. So let's see 46 seconds. So it exited like at 41 seconds. So let me just keep checking that it's okay. It's alive for 16 minutes. And it takes some time to get all the things done that it needs to do for us, for it to present. Okay, 25 seconds. Let me try the port forwarding route again. Hopefully it figured out what it needs to do. Okay, still working on it. Let's check the terminal. It keeps dying. Okay. I am not sure why it keeps dying, but I guess if it keeps dying, I have no way to keep, like, I have to keep restarting it manually. And hopefully that makes sense that that's a lot of work by itself. And even if I have to pass you those instructions to build these two containers, the only way to pass those instructions is to give you these commands. These commands, like, you guys have to copy paste it, but hopefully it makes sense that if there are like 50 containers, it gets really difficult to keep running one by one, or you can write a bash script, but it gets a lot of work. So we want to make this work simple. And that's where Docker Compose comes in. Because what Docker Compose is trying to do is somehow write up something so that you really don't need to, in a very simplistic way, write up something. So you really don't need to keep keep copy pasting these commands. Or even if you create a bash script, you don't have to run the bash script. That script that it writes should be very understandable, should be very English based script. So again, the goal of the Docker Compose is that if something comes to you which has multiple containers, is there an easy way to start those containers all together rather than running the script one by one? And that way has to be very understandable as well. So hopefully that makes sense where the problem is coming and why Docker Compose came. Now, if I go here, so without Docker Compose, we know we have to build one container one by one, uh, and we have to connect it ourselves. And then we have to make sure that the dependencies are good. Like the container that I was running, it needs to keep restarting, and I just have to keep clicking that button to keep restarting to figure out why is it doing that, or why is the application not working, and all that stuff. So I have to do it a lot of work manually. On Docker Compose, on the other hand, it can run the containers. It can run the containers by itself. So that's why it's like an orchestration tool where you can just say, can you run these things by yourself? Can you handle the dependencies? Can you do everything that I will do one by one? Can you do it all automatically within you? And that's what Docker Compose gives you. So that's what the goal of Docker Compose is. Now, Docker Compose basically helps you build multiple Docker images. Uh, I hope this question isn't redundant, but name should be written as -n. Uh, you might be right. Oh, can it be written as -n? I feel like I have to check the flag. So you can always say Docker help, or Docker run help. Oh, Docker help. Or you know what? Rather than CLI, I can just go to Docker-n flag. Hopefully it's name. Let's go Docker flags, Docker run, and I think there would be multiple flags in there somewhere. It just says this. Usually it tells us that what can be a single dash, but I don't see for name it's telling me that. So Control F -n. Yeah, so I don't know. I have to run the experiment. Like there's no fast answer right now. I guess it is not giving me a single -n anywhere. It could be that because single -n can mean network, like there are so many contenders that they might not have made -n flag at all. But it's something that can be experimented on to check. But with simple search, I cannot find anything right now. Okay, so Docker Compose. So you can build multiple images. You can build containerization applications. What does that mean is, for example, Airbyte is basically, if I remember correctly, there are like 6, 7 containers working together. And Airbyte itself is a whole application. Now, running those containers one by one, making sure everybody is talking to everybody would be a lot of work. But if I just go and do Docker Compose route, it's just super easy to do it. You don't have to do it one by one. You can launch full system of services quite easily. So because you will see as I do Docker Compose that that's true. You can manage the state of individual services, like because Docker Compose have way to make sure that, for example, it just keeps on shutting down for me the Mongo Express container. But I have a way in Docker Compose to say, okay, if you shut down, just keep on restarting, like so that it can manage the state of the individual services, as well as you can have all the logs of the services going somewhere which you can analyze or use. Like if any service failed, you don't want to go at individual containers and see, okay, why it's failing, Docker Compose can have a log service in itself that can give you all the logs in one place. So that's why Docker Compose can really make your life easier. And what I'm going to do is I'm going to change my MongoDB Express and MongoDB container into Docker Compose. Uh, and you can see that how easy it is then to turn those container up. The only problem with Docker Compose is that it's not a production system. So you cannot use Docker Compose as part of production. The workflows for production goes a little bit like there are multiple programs that comes into production, but the one that is most famous for Docker for containers is Kubernetes. Uh, Docker Compose is just used for testing, prototyping, or just development stuff or in local environment. Docker Compose cannot create clusters because in production, what you're doing is you're using clusters. That means you're using multiple containers. You are making sure that there are like 5 containers of something and they're always up. Uh, if something goes down, it gets up automatically. And the configurations get a lot more complicated that Docker Compose have those limitations that it cannot go into that system. But now Kubernetes then becomes a DevOps tools. So that's why as data engineer, so for example, uh, I think I use Docker Compose every 2-3 days, but it's as simple as Docker Compose up, which I'm going to show you what that means. And then it gets my application going and then I use that application. Uh, but that's because it's in the local system. In development system, our infrastructure team has already built Kubernetes system, which is in short using the exact same container that I use in my development system in my local environment. But the whole part of that is that it's very good in terms of like it's always going to perform as it's supposed to. Scaling is quite easy there, but Docker Compose cannot do that. Okay, so let's go back and let's try to change. And the whole point here is to show you that it's quite easy if you know how to run Docker commands individually to create a Docker Compose file. So the first thing is, I really don't need this. So Docker Compose, something that comes automatically with it, is whatever containers you are going to open in Docker Compose will get connected to each other. So you don't need to make a network to connect them because they will automatically get connected. Uh, so that's the first thing. Now, Stella asked, what's the YAML file? So YAML file is a special type of file which we use to create Docker Compose files. And this YAML file, you will see it coming again and again because it's a very popular file format, very similar to like text and and there are some like other like sh for shell scripts. Exe I think is for Microsoft's Explorer, or exe is for executable. I think Microsoft Explorer works on exe as well because it's an application. But anyways, so these are just file extensions. YAML file, on the other hand, is a special type of file extension whose goal is to have simple English. So whatever we are trying to tell Docker would be in a much more simpler way rather than saying this, but it's declarative. And the core piece of declarative is we tell it what to do. So I'm just going to tell it, can you create a port with these ports mapped to it? And Docker and YAML file, and YAML files get used in a lot of places. The whole point is to give it some configuration, give it some setting, and YAML file makes sure that setting gets considered and set. So it's like you just tell it and it gets it done. And a lot of programs accept those YAML files. Okay, so for Docker Compose file, the first thing I have to do is I have to write the version. And what this version is it just tells how am I going to define this Docker Compose file. So because it's version 3, there used to be version 1, version 2, and they were changing the formatting of the Docker Compose file based on that. So that's why you have to tell using version. how it would be formatted. We will be using version 3 mostly, but even in your life, if the versions get updated, you can always go to their website and they will tell you what version you should be using for different Docker Compose files. But this is not the version of Docker Compose, it's the version of Docker Compose file format, uh, which is written right here. The first piece that comes into Docker Compose file is services. And you can see that it's just simple English, and I'm just writing things with indentation, uh, and those will get executed. Now, services are your containers. So whatever is inside the services heading is basically the containers you're going to make. So the first container I want to make, I want to name it MongoDB. So as soon as service indentation, I can tell what container I want to make, and that's MongoDB. And that comes the name of the container. You can make it any container. You can, as in Docker, you can name it anything. In Docker Compose file, you can name your container anything as well. The very key piece is this image, which I'm going to use as Mongo. And because I know that they installed latest version, that's why I'm giving it a flag. But if I would have not given it a flag, or you know what, let's not give it a flag. Uh, just get it from here. So it's just to show you that it's the same thing. I can just give it an image like that. Now I can give ports. So ports, and it's again YAML file because you can have many ports. That's why image can only be one, which the container can build. But as soon as you have multiple things, you just indent it and write it like this. I'm going to grab these ports and put it right here. Let me just erase this as well so that I don't have to. Like when this line is all erased, I know my YAML file is good now. So this is ports. Now what else is there? Environment. So again, in a very simple English, I'm just writing environment, and then I go, there are multiple environments. So I will just do that indentation again. This is this. This is this. Perfect. So environment is done. Let's see. Network is going to make it for us anyways. So I really don't care about that part. The image is already, so the name is already there, so I don't care about that part. It's going to be detached by itself, like as it starts, it's going to be detached, so I don't care about that part. So, or it's not going to be detached. I think it won't. I can tell it Mongo in Compose that I want it detached or not. But this is the whole thing that happened here, and it's all good now. Now, because my container kept on failing, one thing I can do is I can just start the restart option in a simple English, restart, and then I can just say always. Now, these are all keywords of a Docker Compose file. So I cannot write like Hamza, like that won't mean anything for it. But restart is a keyword, so you can go to their documentations. They will tell you what keywords you can use, and restart is one more thing. Environment is the environmental variable. So we are creating environmental variables so that as soon as MongoDB starts, the admin and the password would automatically be set on that database. So MongoDB is a database. So that's the username and password to get into that database. And whenever I say environment, these are environmental variables so that it can be set inside the container. Okay, so MongoDB container is all done. Very similarly, I'm going to create one more service, which is for MongoDB Express. So again, indentation is going to stay same. For services, what should I name it? I will name it Mongo Express, for example, keeping the name as same as uh, what I did before. Okay, so what else is there? Let's talk about image first. So the image is Mongo Express. Oh, it's this. Oh, that's the name, Mongo Express. We'll get rid of that. That's the image. I will do restart again because the container Mongo Express kept on failing. So I will do restart again. Let's do ports. Let's grab ports. Instead of rewriting it, I can just write it right here. And then it's 8081. Okay, let's do environment as well. Very similar to what we have. And I'm going to give it, that's my first environmental variable. And that's my second environmental variable. Okay, what else is left? Network is going to happen automatically. Name is already done. I'm basically done with this. We'll remove that. And I think, let me shut down the containers as well. So Docker ps-a, Docker remove. And you can always use container ID, remove things as well. Oh, you have to stop first. Okay, we stop it. Okay, that container is already stopped. I think this one should be stopped too now. Okay, Docker remove. And then I can also use a variable saying Docker ps dash a q for quiet. And then, so if I do Docker ps dash a, you will see that it's all empty, which is great. Now I have created this file, but in order to run this file, I need a program called Docker Compose. So I have to install that program. And in order to install that, we will go through this use case. There is this documentation that you have to go through. So if I go here, it's going to show you how to download that. So I'm just going to copy this. And then it's going to download it. Let's go make it executable. And let's go. Oh, I guess all users can use it too. Okay. But that should be executable for us. Let me see if we had Docker Compose version now. Ah, okay. So I do have Docker Compose running now. Perfect. So it's all installed. Let me clear it up. And now the only thing that I have to do is ls. I have to cd into Docker ls. So this is where my file is. And I just have to say Docker Compose up. And you can see that it I didn't detach it, but it automatically basically built those containers for me. So it created the network for me. It created the container for me, both of those containers, and it started running. And I can see as these logs are coming, where these logs are coming from. So that's good because they are all mixed up together. So I have one place to look at the logs, which is great. Now, if I port forward it to 8081, I am not sure why this is. Uh, hmm, Due to some reason, this is not working, but I can definitely troubleshoot it. Both of my containers should be running quite simply. Okay, let's see. Welcome to Mongo Express. Uh, Let me see Docker ps-a up for 4 seconds. Okay, I think Mongo Express is going through some problem right now. Okay, I will troubleshoot it later. This should work. Anyways, uh, let me go back here. But the whole point is Docker Compose did help us to create those containers for us, and then it's restarting Mongo Express as well uh, as we need to, which is great. So all those containers become really, really easy to create and work on. Okay, so let's go a little bit deeper on different things in Docker Compose. First is the Docker Compose file. So we already created a Docker Compose file. Uh, for Docker Compose file, the only thing is that if you name your file as docker-compose.yaml and you are in that folder, it's automatically going to pick that file up. So you don't have to tell it what file to use. -f is only used if you name it something else. So if the Docker Compose file is named something else and you can name it as mongo.yaml or something, you don't have to use that Docker Compose. Like you don't have to give that. You then have to give that -f. So for example, if let me go back. Let me say, and in order to get Docker Compose down, now one more thing is that if I try to kill Docker Compose, because restart is always, because I can say Docker stop. Let me see what ps-a I have. So I can say Docker stop and give it, like, for example, MongoDB Express 1. So if I say stop Docker, and now if I do Docker ps-a, okay, let it Docker ps-a, 7 seconds ago, okay, Docker ps-a, it should Docker ps, because one of the things which Docker Compose can do is it can make sure that your containers stay in the status that you give them. Uh, in order to get all the Docker down, I can do Docker down. Because I'm out of that file now. Okay, ls cd Docker. I can do Docker Compose down, and it will just get those containers removed for me. If I do Docker ps-a now, there's no container, so it will get them removed. While getting them up should be very easy because it's just Docker Compose up. So then it start going, grabbing that container for me. So, but one of the things was this, that if this file is named something else, then Docker Compose will stop. Like I have to give -f to tell it what file it is. Let me shut the container down. Uh, okay, now what else is in the Docker Compose file? So now we will go deeper into Docker Compose, different parts of Docker Compose file. So the first is layer 1, which is the version, which is the format of Docker Compose file, which we already saw. So you can get the format. Now format, there's for version 1, version 2. So all the future versions are compatible. So even if you have version 3 format, version 2 format still works because they made it compatible. So that's one good thing. Now let's go into services. So services, we already talked about that. It's all about the containers that we want to create. So that's where services comes in. And it can, you can define different applications, and it's for containers. Networks are optional, but for Docker networks, I guess the best way to talk about Docker networks is to go to the whiteboard. So what for Docker network, how does it work is, so I guess there are few things that Docker is doing. So on your EC2 instance, let's say, there is like, I'm just making it a socket, which is where internet is going in. That means it has access to internet. So this is like a public access that you have. Now, what happens? It goes through multiple network pieces. I won't be going into those network pieces, uh, but these are your EC2 instance network. So, for example, if you open a browser in your EC2 instance, it is this network that it is going to go through, and then there are some checks that this network has to go through before it can get exposed to public. We know that for network we have security groups. So this would be one of the checks that this network will be doing in order to get out of cloud, because this is the EC2 instance limit. This is the cloud limit. That's where VPN comes in to make sure that uh, your cloud is secured. But along this network is where a network called Docker Zero. So that's the name of the network that Docker creates. It's called Docker Zero, is attached to. So that's the network which, as soon as you start the Docker daemon, it automatically creates that network. Now, Docker Zero, there's another name, and that's why when I did Docker Network, you saw that there was something called Bridge Network. So Docker Zero is also considered as a bridge network. It's a bridge network as well. So if you see it, that's what the network uh, is happening there. Now, if you if I so the network that got created by Docker Compose by default, what happens is, so for example, this is your container, and these are the ports. So whenever I define ports, this is the attachment port that I am defining. So what I am saying is take this container at 2707, for example, for MongoDB, and attach it to your Docker default network at port whatever 27, like, and these ports can change. So that's why the port that is coming from the container has to stay same, because container has already determined that they are going to send some traffic to this port. If I attach the container on a different port, there won't be any traffic coming in there. So that's why that port can stay same. But the second port, for example, instead of attaching it here, I can always attach it there. So that port can always come. So if I name this port as 1 and this port as 2, in your dash p, whenever you talk about Docker and you give dash p configuration, you always give container port first and then your local host port second. So that is what 1 and 2 means. Uh, to uh, that's what you're basically giving. Let me just check. I think container port first and that port second. Let me just confirm that, because I always mix up these two ports. Let's see. Okay, so it's yes. So it's container port first, and then comes no your local computer and then port of containers. Okay, sorry, it's the other way around. It's basically 2 and 1. So 2 is your local computer port and 1 is your container port. You cannot change this. This is already determined by the container. You can change this because you can put it anywhere, because all the ports are basically going to your local computer anyways. So that's what the bridge network is. And this is my container. So C1, that comes C2, and then it will just keep attaching to the bridge network. That's the bridge network. Now there is a second type of network that you can configure. So, and it's also coming out of bridge network. So let me erase this so that I have a little more space. Docker Zero. And then that network is like, for example, this would be your user defined network. and you can put containers on that user-defined network. Now, the difference between user-defined network and directly connecting to the bridge network is in user-defined network, these containers has to go through your network rules to be able to connect to the Docker zero network. And here you can put what type of traffic can these containers accept, not accept. So there is a set of rules that you can introduce right here in the user-defined network, which will make it difficult for these two containers to talk. On the other hand, if there are two containers sitting right here, they will talk regardless because they are on the same network. So any container on the bridge network can talk to each other, but if you create a user-defined network, and then put containers on that network, they won't be able to talk to bridge network if you say that this should not be allowed, or you can control the traffic that goes in there. And now because we are doing microservices, we can make such things happen. Because for example, if you have an authentication container here, you can only say that this only traffic that is allowed to be port to allowed to go to this network has to go through authentication container, or they have to pass something that allows this to go in. And that way your site is secure. But if you have authentication network here and your, like for example, your main site database here, then people can go here, and even if they are not modified, they can go there. So that's why those network comes in, just to give that boundary uh, on your microservice, so that traffic cannot go if it's not allowed. And then I think one of the network that came in was null, and this null network is the network that goes nowhere. So if you attach a container to this null network, you're basically done. Like that container cannot talk to anybody. So super secure containers that we want to run by themselves, not attached to anyone, goes onto the null network. Uh, so that becomes your group of networks that Docker allows you to create. Now, these creation of these networks on Docker Compose file is easy because, for example, if I go back to the nodes, you can see that here in Docker Compose file, they were just creating like front end is a user-defined network, back end with a special type of drivers as a user-defined network. So you can create all those networks just in this format, which is very simple English, rather than running networking commands, which makes it a little more difficult to do stuff. Uh, Volumes. So we talked about volume in the last lecture. There are three ways you can do volume. These two ways, normal volume and named volume, are kind of same because these are what is called Docker volumes. On the other hand, this is called bind mount. So let's talk about bind mount. We already talked about it last time. Where here, what we are doing is we are defining exactly the folder in your computer this volume should bind to, and that's why it's called bind mount. Uh, in best practices, this is not one of the best practices because user can have access to this folder. There could be like Docker is not controlling this folder. You are majorly in control with this folder. So it's not recommended until unless it's absolutely necessary. Like you have a use case, and there might be use cases where you're like, okay, I want to get this file easily accessible, and it's so much easier to get it from like if I mount it on my like right here in my computer, rather than letting Docker take care of it. But the best practice is to let them take care of it. And there are two ways they can take care of it. Number one is called normal volume, where you don't tell it the name of the volume because it's going to create a hash. Hash is just numbers together, like multiple numbers together, uh, like AC392, like a unique name, which you can go and check. If you go into that hash, that volume would be there. On the other hand, there is named volume as well, where you are telling it a name rather than giving it a hash. You are telling it a name, and then it's going to get created with that name. This is mainly used for if you have multiple containers that want to access the same place. You can name it, and you can name it in all those containers as well, and then they will just keep working on the same file. So name volume has that advantage added to it. Containers. So now let's go to containers. So we talked about that it has to come under services. You can name your containers anything, and they are built on the image. Now, because as data engineers, you won't be writing your own, building your own Docker images. Uh, so mostly you would have either image provided that so this image will get downloaded from Docker Hub, or they will give you a build image. And if they give you a build image, you just put that image into your folder, and that usually the image is called Docker file. That's how the images are created. And then you can just say build, that's the keyword, dot. That means whatever Docker file that you find in this folder, just start running it. So that would just build that image, whatever is in that folder for the Docker file. And then comes the port, where first port is the host, the second port is the container, and those are the ports that I was talking about in the network part. Uh, and yeah, it's super easy to define just by this keyword. Now, as a part of container, you can also set volumes. So you can set the main volume, or you can set volumes as a part of the container. That means this container would have this volume, this container would have this volume. So containers have a configuration for volumes as well. Depends on is it makes sure whatever the service depends on, it makes sure that the other services are already running. Otherwise, it won't start. So that's what depends on that it keeps on checking if the other services are running. Only then the container that it's defined as part of starts. And then comes the environmental variable, which is what we declared in our example, which is just the variable that would be part of the container. Uh, uh, and you can, if you go into the container, you can search it up, or they will set, like, for example, username and password, that if you want to log in into the application that container is running, those are the uh, all the are the variables you have to provide them for it to work. Uh, Other than that, there is a keyword called command. So as soon as the container starts, you can also, so if you have a container and it starts, there are few ways of running that container. The first way would be or running commands into that container. So there are few ways to run commands into this container. You can go and run the command by yourself. Like you can do docker exec IP with the container name bash, and you can run this command. Or you can just identify those commands as a part of your Docker Compose file, and they will automatically run. So, which is pretty good. So that way you don't have to go in. If there's a command that whenever container starts, you have to run, you can just run it as a part of command keyword. Then comes the restart keyword. So we talked about restart, where what will containers do if their status is going down. So there is no, that means you don't really need to restart them. There is on failure. So if the container has an exit code non-zero, that means container exited because of a failure inside of it. It will restart, and then you can also tell it how many restarts it needs. So for example, after 3 restarts, you're like, okay, don't start it. There's a bigger problem. So I will come and check it afterwards. So you can give that maximum tries as well. Always means doesn't matter. Just keep on restarting the container. So that's what this would do. And then unless stop means if it's stopped, then don't restart it. Otherwise, keep restarting. And then comes the Docker Compose. So Docker Compose, so these are some of the commands. So Docker Compose build means if you have the image, like you're using a Docker file, you have a build image defined in your Docker Compose file. This will just build that image. So this will just go and build that image. Up and down is just starting the Docker Compose up, and Docker Compose down is just stopping and deleting it. Stop means stopping it. Down was removing it as well. This won't remove. Restarting means restart all the containers in the compose file. TS means whatever is running, and then remove means to remove those containers. Uh, and I think remove only works for the containers that have been stopped. So basically, down is a composition is made up of stop and remove together. Now, these are some commands for Docker Compose, but I think there is a much uh, bigger command for Docker Compose here. Let's see, Docker Compose file, commands. And then you will see that there is a bigger uh, like that means that there's only not those commands that are written there. Like there's much more commands in Docker Compose that you can use, but those are the few ones which you will use every now and then. So those are some good commands to know. Uh, One more thing is here, there is dash. You will see that when I was running Docker Compose, I didn't have a dash. The reason is they updated the version. So this dash is still compatible. So you can do Docker dash compose. But I don't know if they will stop that compatibility. But in order to run the newer version, you have to, like, there are some commands which won't work if you're using this. Uh, in order to use the newer version, you have to use it without dash. So like you can see that there's no dash here. Uh, so that's that. Uh, any questions on Docker Compose? Okay, so I guess, let's take a 10 minutes break, and then we can go on to the project that we have and how we are using Docker there. And after that, we can go on to the data engineering part. So let's take a 10 minutes break, and then we can come back and work on project part. Okay, let's start back. So I guess I was trying to troubleshoot why this is not working. And what it ended up being is I wasn't defining. So one of the environmental variables were missing, which was this MongoDB. So it was trying to look for which server to connect, but Mongo Express didn't know where to go and which server to connect. As soon as oh, uh, I put that variable in, now it's running. So show you right here. So I think my password is admin and password. Username and password was admin and password. So these are, yeah, it's admin and password. Admin, password. Ah, that's a newer problem. Admin. Is it root in example? Okay. So I guess now the password is not working, which is like I just gave it there. But I can, yeah, I will troubleshoot it afterwards more. But for now, at least Mongo Express is working because of this configuration missing. Uh, but I will troubleshoot it further why the root password should work, admin and password. But anyway, so that's so sorry about that. But your container should be like if you just add this configuration, your container would work. Uh, Anyways, I will stop my Docker compose down. So it will cd docker compose down. So it will just get rid of all the containers that I have, and this will get clean. Okay, so let's go uh, to the project part. So for the project, what is going to happen, and this is this week's lab as well. So, ah, it's not okay, so this is this week's lab as well. But what you're going to do is you're basically going to uh, install Airbyte and Metabase using Docker. So as always, you have to run all these commands to install Docker. Docker Compose is right here as well. These are the commands that I ran uh, from the website. These are the exact same commands. And then you make sure that this error gets done. Uh, you reboot your instance. Uh, I didn't do that, but if you get stuck, it's always rebooting is always good. I didn't have to do it, but it just takes a few minutes to get it done. So what it's going to do is it's going to restart your EC2 instance uh, so that all the changes take effect. Now, here is the main part. So I think installation part is simpler. Like I think you guys should be able to do that. So now this is Git. Uh, so I'm hoping some of you would know what GitHub is. So GitHub is a place which where you can keep your code and people can then use that code as per their needs. Uh, so what's going to happen is we are going to install Airbyte using GitHub. So because Airbyte is open source, all the code is available. Uh, and what's going to happen is as soon as so as you install all of these things, uh, there is this sh shell script that you have to run, and this is based on Bash scripting. So this is a shell script, and it's a pretty complicated one. So these are the type of shell scripts that you see around. Usually, you are not the people who are going to write it. Uh, those will be written for you. But what it's doing in the end is basically it's running Docker Compose file. So you can see there is a Docker Compose down here, sorry, up there. So it's just running a Docker Compose file, which is basically getting all the infrastructure up. Now, if I go to uh, this shell, so basically you need this script uh, to run it, and it takes few minutes. So that's why I won't be doing a demo, but you guys will be doing it in the lab. So if you guys have any problems, we can troubleshoot it together. Uh, but it's basically this that you have to run, and you will see that I think there are 5 or 6 containers that will automatically get created because they are part of Docker Compose file. Uh, and then once those containers got created, they will tell you, okay, you're ready, go to 800 uh, to get connected, and then you can go on 800 and your Airbyte instance would start. Uh, I won't be running it right now because this will take a little bit of time. Uh, but so this part you don't need to do if you are running on VS Code. You can just adjust port forwarding to do it. Uh, but I can quickly do this metabase because this is much more straightforward. The container itself is not that big. Uh, so it's basically you have to run. So for example, it's just going to grab the metabase image and you run docker run metabase. So it's just going to start building on that image. Uh, so if I do docker ps-a, you will see that metabase is up. Now, the only problem that you're going to get stuck is even if I port forward it 3000, uh, you won't be able to see it. So, okay. Okay, so it will take few minutes to start up, but even if I do this, okay, it's still running. So you can see that it's slowly running and building the metabase. Uh, okay, and then I guess it's just this. So this is a whole application that you can basically install as well as a jar file. But you will see that it's going to get installed and take time. But right now, when it's running with Docker, it's just much more faster. So you can see that the whole application got up so much faster. Uh, so that's one of the advantages of Docker. But that's what you are going to do in lab. Airbyte is going to take some time, but Metabase should be pretty fast. So you can just do Docker stop Docker ps-aq and Docker remove Docker ps. Okay, so that's how much you need. So I guess for our project, that's basically how much Docker you need to know because that's all the Docker that you will be doing. Now, there might be instances where you might have to troubleshoot a little bit, but I think the Docker part is pretty straightforward. Uh, and yeah, if you have problems, you can definitely troubleshoot it after ourselves. Like we can troubleshoot in the lab. Uh, now, any questions on Docker? For the install Docker part, can you quickly explain this command? Docker config home or install Docker part. So, uh, so this command. So let's see. So set a Docker home folder and create a CLI plugin directory for Docker Compose. So this is just setting a variable where. So okay, I think it's much better to explain just by running it. So if I do this, and then if I do $docker config, uh, sorry, echo docker config. So you can see that it's just setting this directory up. It's just setting this directory up. So if I see it here, so it's saying if you have Docker, so you take just home. This is where the home is coming. If I do echo home, you will see it just gives me this, and it's just adding this part to it. So that's all it's doing. So if there is already Docker config set up, it's going to add to that Docker config. If there is nothing set up as Docker config, then it just adds this as a Docker config. So yeah, it's basically setting this directory up. Hopefully that makes sense. And any of those things you can just uh, yeah, just run it on terminal and it will show you exactly what it's doing. Uh, I used the YAML file before the correction on environmental variable. It's not successful completely, but I rerun the YAML file. Which command is to remove the container in the previous installation? So you have to do Docker compose down and it should remove all the containers that were made through Docker compose. But you're saying that, so I don't know if you have like, you still have two containers or you have five, like how many containers do you have right now?
I can see two currently on my Docker Compose, but that's under the previous setting.
And you cannot do Docker compose down.
Yeah, I mean I can do, but like there are several options like down or stop. I'm wondering like what is the appropriate one to use in this case.
You can just do down and it will stop and remove it together.
Okay, got it.
So that would be done. Uh, depend on, okay, yes. So so this was one of the troubleshooting step that I was trying, because what this means is don't start Docker Mongo, don't start Mongo Express until Mongo is up. So that is what depends on is, and I'm like, okay, is this not working because of that part? Uh, because even though I'm restarting it always, I'm like, if Mongo is up and then it restarts, it's basically replicating what's happening here. But I'm like, okay, let's give it. But even if I don't give it, my results should not change. So if I remove it, Docker compose up, I think like this was the key variable that basically resolved it. So now if I try to open it, I will still open it, but then this username and password is not working due to some reason. Uh, let's try it again, which I have to see if there is a password that got configured somewhere else in documentation that I have to give here or something. I thought this is the main place where I'm setting the password up, which is right here. So I thought this is going to work, but I have to dig into documentations to see if there's something else happening in the background that I cannot see right now. But yeah, so if you even remove that, it's going to work. So hopefully that makes sense. Okay, any other questions before I move to uh, just the general data engineering? Okay, okay, let me change my screen. Can you show me again how to bring up the username and password window? Okay, uh, let me keep sharing the screen then. Okay, so do you mean like, I don't know if let me see if my containers are up. So once you give the port to 8081, you just have to click this forwarded address and it's going to bring that up uh, right here. It's basically this forwarded address. Just keeps on opening on a different screen, but yeah, just brings it up. So that's how forwarded works. Hopefully that answered your question. Okay, let me just turn it off. Docker compose down. Okay, it's removed. Okay, I can go to my other screen. And okay, so data engineering. I don't know, like I heard that some of you people are already data engineers, so something that I'm going to tell you might not be new for you. Some are data, like they are part of data, so they might know the roles, and they keep on like they're just sometimes they just keep on changing the role names as well. Uh, but hopefully, the people who are new to it might gain the most out of this. Uh, but I just want to go through what really is happening in data engineering. What is the goal? Why are we doing all the things that we are doing? Okay, so the first thing that I want to talk about, let's make this a layer that's called sources. And by sources, what I mean is basically data sources. So these are the sources that we want to analyze, and they come in a lot of forms. So, for example, website. So, if you go on any website, there is a lot of data being collected as you're interacting with that website. Like for example, if you go to an e-commerce website, as you are clicking different links, they are collecting data. Which part of the page were those links? They are collecting the data about it. How did your journey go? Which link did you start with? Which link did you end with? They are collecting data. Which source did you came from? So is there a marketing source? What link did you came from? Was the link that you came from through Google, like it was just you Google searched it, or was it from Facebook or Instagram? All that is being collected. So there's a lot of data. Any organization that is a website is going to collect a lot of data, and that data just flows and we can understand our customer quite a lot using that data. So hopefully that makes sense. The second source that I would say that is pretty popular is mobile apps. Any app that you have is collecting data as well. Very similar to the website data. App is just app. So as you are clicking through it, it's collecting data. And that data is helping them improve results as well as they get to know you more through that data. So that data becomes our sources as well. The one more source is the third party data. So now all the data that we have right here and here is something that we built ourselves. But in order to understand, for example, if your company is looking to understand where is the most of the traffic coming from, they might need a map. They might need longitude and latitude data because it could be that this website is going to give you some data. Like for example, it gives you the IP address of the user that is interacting with the website. But you need something that can help you convert that IP address into a location. And these web systems that you made might not have this. So you need the third party data so that you can make this data usable. So what we do is and this third party data can come through an API. What API is basically an application where you can ask questions. Like you can say, give me the data of all the IP addresses that start with 163, for example. And that API is going to query, it has a lot of data. So it's going to query that data and give all those data points to you. So whenever we are looking for third-party data, it's usually to enrich data that we already have so that we can make it more usable, we can understand it more. And that's the whole point of that piece of data. Now, the third, one more piece that is quite popular is the customer data platform. And it's becoming very popular uh, because people are having, so companies are having multiple sources of multiple places where they host customers. So for example, if your company have a website and a mobile app, some customers are going through website, they are interacting through website. Some customers, on the other hand, are using mobile phones to interact. But they have to understand if these two are same customers so that you can understand their behavior. And this is just not happening through one application. You can have multiple applications set up, multiple ways which customer can interact with you. Like you can have physical stores data, like physical stores people can visit. And then you're like, okay, this person visit, does he give me any data points so that I can attach to how much time did he go to the website, how much does he use my app or not, how what is he clicking. And these customer data platforms, and I think one of the most example that's quite popular, the application that's quite popular in this segment is called Segment. It's called Segment as well. And what it's doing is basically reading all the data coming from all these platforms and trying to recognize uh, if those customers are exactly same, so that you can make a holistic view of the customer that you have. Other important systems are ERP, which are called enterprise resource planning systems. Uh, One of the popular system in this segment is called SAP. And here the goal is to understand, like if you have a manufacturing facility, if you have like how are systems inside your organization working? So for example, people can create work orders, which means like for example, in a construction facility, what you do is you create a work request first. So first comes work request, where you're like, can you get this work done for me? Somebody then creates a work order, which is like, okay, let's plan this request out. Let's see how this can be done. Uh, how can how it can be done, and then that work happens, which then closes the work request and the work order itself. So it could be that, for example, in our company, we have a system where we go and install internet into people's houses. That's one of the companies that we have. And in there, what is happening is people are like, okay, I need internet store installed. That becomes a work request, goes into the system where you are keeping track of all the requests that are coming, which one is first, what materials are needed. That all that information goes in, and then becomes a work order where you take those material. The person, the installation guy goes, install the stuff, and then that is closed. So it's quite important data for your company, which is all flowing in there, and you're keeping that data as a part of ERP. Then there are finance systems, like these are specialized finance systems, like where all the finance part, how much profit you're making, all that stuff can get stored. And such systems, like very similar to those systems, there can be marketing systems like Facebook Marketplace data can come here. If you're marketing in LinkedIn, that data can come here. If you're marketing in YouTube, that data can come here. And very similar HR data, there are applications for HR. So hopefully it makes sense that you have a lot of data sources. And all of the companies have this. The reason why they create data department is to understand how, if these sources can combine together and give you a part of truth. For example, if you want to understand your revenue, but you want to understand what piece is this revenue coming from, that means like what product is this revenue coming from, your finance data alone is not sufficient to tell you that. Because your finance data, usually what happens is finance data is based on ledgers, which is basically it's some type of service, and those all services are coupled together, and you don't get and then you get the total amount that you get out of those services. So if you have 50 products, it will just couple those 50 products together, and you know the total revenue part, but you don't know the individual pieces. And again, there are different ways to put those applications in, but mostly the data is very aggregated in those systems. So in order to really understand where are those products coming in, you have to use ERP data. Now, ERP only tells you when the customer becomes your customer. But how did he become your customer? What type of marketing helped him? That data is coming from here. And then it's like, did this customer interact with their website? How was the interaction? How was their behavior? Is it possible to convert them to make them your customer way before? That is the data that will help you there. So hopefully it makes sense that one, like, these data pieces are not enough to give you the information you're looking for, and you have to figure out a system so that these can be together. And that's where the data engineering or the data journey starts. How to make these systems give meaningful information by bringing them all together. So let's go here, and that becomes your sources. Now, based on company needs, different companies move different ways along this. So I'm going to discuss some of the popular ways, but let me discuss first the something that is called, okay, let me discuss a way, and then we can build on that way a little more. So for example, this is quite popular way. And the first thing that comes in this infrastructure, let me refresh it. My sources will go away. Let me start. So hopefully sources make sense. Now here comes something called loader. And what loader is doing, okay, and among all the other sources, there was one main source which gets used quite a lot, and those are operational databases. So these databases are basically like your website data can be fed to operational database. It's just a place to store the data. So among all those sources, there could be operational databases that are housing that data, because again, you need a place to store website data that is coming through, and mobile data that is coming through. So what you do is you can put that data into their own operational databases, and using that database, then you can grab the data to get an analysis done. So I just want to share that keyword. It just means it's a place where data can be stored from a mobile. But these operational databases have, like, mobile would have their own, website would have their own. If you have a CRM, so CRM is one more source, which is customer relationship management. As your salespeople are reaching out to the customers, they're identifying if they called them, how the relationship is going. That will get stored in CRM. How will it get stored is using operational database. So operational database, CRM would be using operational database, and that's where things are going. Now, before you can start analyzing all these different sources, so there are a lot of different sources here, you need to load it. And where you need to load it is, for now, the place that you want to load it is called data warehouse. And what this place is basically these operational databases are there to collect data. So they are optimized in a way that the website that is feeding into this can easily feed that data into it. Like they are optimized in a way to put in data into databases. But what this data warehouse is there to analyze data. And when we are analyzing data, what we are really doing is we are doing a lot of computations. We are doing a lot of I I don't know how good you guys are in SQL. A lot of grouping. That means uh, you don't really need to know if one product got sold to one customer. You really do not care about that record. You care about multiple records coming together to tell you how much did you get, how much revenue did you get from that product, because that's the question you are more likely to answer rather than which customer bought what. Like what did Hamza buy? That's just one record in the table. You are not very interested in that. You are like, the product that Hamza buy, how many other people bought this product? So you need to group that data to understand it. And these places are optimized to do those things. And that's why they are called, they are analytical databases, exact same, that means exact same thing. But these are the places which are optimized to analyze data. And there is a difference in their architecture. That's why they are getting optimized to do those things. And we will talk about those architecture changes in the future. But in order for these sources to go into the data warehouse, which for us, the data warehouse that we will be using is Snowflake. There are other examples of data warehouse like BigQuery is example of data warehouse. Redshift is example of data warehouse. So these are all the data warehouses that are out there. You have to grab data from all these sources and put it into this data warehouse. There are a few ways to do it. So there are something called SAS tools. These tools are like Fivetran, if you heard about them, Stitch. And what the goal of these tools are is just grabbing this data and putting it into these data warehouses so that they can be analyzed further. Now, the other part is you can write custom Python scripts, not Python, any language, but custom scripts you can use. So for example, if there is some data that is coming through API and these SAS tools are not providing you a way to connect to them, you can always write your own scripts. And next week, when we look into Python, we will learn about a package called request, which is basically going to help us write those scripts in our, if you see AWS Lambda, so in our project, we do write a custom script to get some data out, and that happens quite a lot as well. If the SAS tools are not good enough, you can do that. And then the third type of data, which I want to discuss, is the streaming data. Streaming data is getting quite popular, especially in companies that have to react to that data. What does that mean? For example, if there's a company that has to analyze, like that want to analyze how many orders did we get in last 5 minutes. So they sell quite a lot and they want to analyze how many orders we get in last 5 minutes. They would have to look into streaming data. So a lot of these databases, they are looking for batch data. So there are two keywords here. So one is called batch data and the other one is called streaming data. The goal of the batch data is that let these databases get filled with data, and once a day or twice a day, whatever frequency works for you, but a long period of time. So it could be 12 hours, it could be 24 hours, whatever works with you. You're going to take all that batch of data and then load it into the warehouse. That's one way of doing it. Streaming is much more smaller. Let's take 5 minutes. Let's take 1 minute, because it's some data that is super reactive. So you want that data to come as soon as it gets updated. And in order for streaming to work, some of these platforms are not good enough. And there are new platforms, like if you heard about Kafka, if you didn't hear about it, you will learn about it anyways. In phase 3 of the program, AWS offer Kafka, which is called AWS Kinesis. So all those tools come in this moving streaming data uh, into loaders. But in the end, one of the infrastructure that I want to talk about uh, is the goal of all these things is to put the data into data warehouse. Now there are exceptions to it, and we will talk about it later, what the exceptions are. But you are putting it into data warehouse. Now, what's going to happen as soon as you put it into data warehouse, the data warehouse then divide things into, and there are different names of these layers, but and different companies use different names, but hopefully these names are understandable enough that we can use it right now. Some people use bronze, silver, and gold layers. Uh, so what is really happening is, based on these loaders, we load this data right here, which is, we are loading these tables as it is. So for example, this one table goes here, two table, and these are not just one tables, like this can have 100 tables. So, but the whole point is that we are just putting tables there, because we have to figure out how to combine these databases so that we can get the answer out, because all of these different databases have different pieces in them that can help us use the answer. So all of this data, the loader is going to put them in kind of a raw layer. That means nothing is happening. But then in order to extract things out of this data, you start joining them, and you have to clean them. So you have to join them, you have to clean them, and all that stuff. And that usually happens in intermediate. And then there comes the final form, which is like, for example, this is your sales table. So it has all the sales with all the information uh, of what sales happen, which source did it came from, how many touch points to that customer you had, how many times did you contact that customer. It will have all that data in it because you made it based on these multiple sources joined together. So that's where these things comes in. Now, these models, so these transformations, so these are all called transformations that are building this in the end. They are just so many transformations. Like, for example, right now in my company, we are layering these 300 models, DBT models. And what the place there where these transformations are happening is called DBT. So that's the tool that is helping us put these transformations together so that we can combine all these things and give it one table which has an overall idea of how the business is working. Uh, there are quite a few things that is happening in this layer. And as a part of analytics engineering, so anytime you heard the word analytics engineering, that's the phase 1. You are basically living in this layer. So this layer is very, very important to you. Why did it stop working? Okay, just a minute. Let me share my screen again. Okay. Hopefully this works. Okay, anyways, I think I would have to do some reason. Oh, now it's back. Okay, so and as an analytics engineer, I hope you guys can still see my screen. His Zoom is telling me
I
you
can
can.
see it.
Oh, okay. Thank you. Thank you for covering that. So analytics engineer, basically, that's what I am, is basically looking after these transformations. Now, because these transformations are extremely important to the business, because if any of these transformation doesn't work, the reality of the business that you're seeing is not going to work. Because usually these tables are the one which like a CEO or CTO or CSO, all these big people, as well as the teams around them, are using to make business decisions. So if any of these transformations stop working, that's a big issue. And some of these results, everybody is waiting every single day for these results, because as your customers are reacting, going to use that data to understand the reality of your customer, create products around it. So then becomes a very important piece is number one, how should these transformations look like? And that's what's the part data modeling is called. So what data modeling means is how are we getting from these many tables to these many tables in a way that is scalable, because these data is not going to stop. There would be a fourth source that you have to load. There would be a fifth source that you have to load. And you have to put all that data into this one. So it comes as one table, but there are, hopefully it makes sense. There are a lot of tables, but those are all decision ready tables. They are giving you all the reality of your business in a form that you can look at. So in order to understand how this whole infrastructure will look like is the data modeling, which we will go through. Then comes one more important keyword that's called data quality. So you're not really making this system scalable, but you have to understand that any data that end up here is really the true form. So you have to write, so usually we write tests to say, if this transformation is taking this table from this to this table, can I check if this form is exactly what I thought it's going to be? And that's what becomes a data quality problem, where you're checking if the transformations are running right. And these transformations are everywhere. So you're checking them as they are happening, so that you don't give that business reality in the end to be like, you're like, okay, this person doesn't even know, like for example, your sales are quoted as 0 when it should be 10. That's a problem, because some decision can be made wrong because of that being not 0 to 10. So hopefully that makes sense, that we have to understand if this number is right, and that's where the data quality problems comes in. One more keyword that gets thrown around is called data governance, which means if I am sitting in this sales table, and as an analytics engineer, if there is a discrepancy like $10, I have to understand exactly where that discrepancy came in. And because these transformations, like for example, in my case, it's 3,000 transformations, tracking that to the source table where that happened is a lot of work, because you have to swim through all the analysis and you're like, okay, this is where it came from. So data governance is kind of helping us answer two things. Number one, it gives us a kind of a data lineage. How are these things traveling, so that we can easily troubleshoot where the problem started, as well as who should I contact for this to get fixed, like this source one. So there is somebody who is like managing the source, who should know that there is something wrong happening in the source, and that gets defined in data governance as well. The leader of the source, or the person who is responsible for that source. And so hopefully that makes sense. Governance is helping us control all this data, and governance is also a piece where it's like, okay, this one person can see who bought it. So one person can see in this sales table that Hamza is the one who bought it, uh, who bought whatever is looking, but the other person shouldn't be able to see it because of the security rules. Because it's like the person who cannot see it can doesn't have to see that data, because he doesn't have to do anything with the data. So you have to put the security things on top of that data, saying whenever this person query, don't show the name of the person who bought these things. But when this person query, you can show the name, and that comes the data governance piece on it. And there are a lot of tools. So everything, data modeling, there are few concepts that come here. Data quality, lot of tools come here. Data governance, lots of tools come here. So this is a greater uh, category, and then there is a bunch of tools that comes and talks about those things. Now, as these models are being made, so dbt is helping us define those transformations, but sometimes what happens is it's really difficult to orchestrate those transformations. What does that mean is is you want some place, and I guess dbt can do a lot of stuff. So there, but there are, but I guess once we go into that topic, we can talk about data orchestration in much more detail. But what is happening is you have to time all those transformations. That means this transformation has to happen first. Then this table has to be checked that everything is good or not. And then this transformation has to happen. So hopefully it makes sense that it doesn't make sense to have this transformation first and this second, because that's how the data travels. Otherwise, the data that you're going to get, there won't be anything in this table. And when you go ahead from this table, there's nothing basically. So you're basically doing nothing if you run this transformation first. So there should be systems that are controlling, okay, you go first, then you go. And because there are so many models, there are specialized uh, applications that comes in the data orchestration layer, whose the whole idea is what goes first, what goes next. Uh, uh, is my data here arrived right? Okay, it's arrived. Let's go ahead and keep building our system because I have the data that I need. And that's where data orchestration comes in, and there are so many tools that comes there. I guess I talked about a lot of things. Any questions? Hopefully it's making sense. Okay. Okay. So analytical engineer is living here. Usually, these loader systems, so that's where there is a divide. So there are data engineers who just focus on these loader systems. So like in a bigger company, you would have data engineers and analytics engineer, where analytics engineer is making sure everything is going good in here. And in order to be a good analytics engineer, you need to know your business, as well as if more data comes in, how scalable things are, what type of things should I use so that my system goes faster. How am I going to orchestrate? Like, how are these transformations laid out so that the first one always be this, the second one always be this, or something like that? That's where analytics engineering come in. But if you're not interested in domain at all, then comes these data engineers whose work is to make sure that these loader systems are working right. Okay, go ahead, Anna.
Oh, I typed in chat, but where does the DevOps engineer sit in this?
Okay, so DevOps engineers, where they are sitting is basically, okay, now this loader system, for example, is there are configurations part of this loader system. Like, for example, this loader system has its own configurations. Like the data is passing through it, but you have to configure this system as well. So DevOps usually work on that. So the whole point of DevOps is to make sure that your systems that is making update, not the script itself, but the system, like Fivetran is working, Stitch is working, uh, DBT is working right. They're not thinking about the data that it's processing through, but the system, what DBT is supposed to do is the version of DBT that's being used is good. Should we go ahead and update it? is there a DBT container that is going down right now multiple times? Let me go and fix it. You're using Snowflake. Okay, is Snowflake working right? Like, does it have all the compute power and storage that it needs? So all those uh, are the questions that a DevOps or a data infrastructure engineer would answer. So hopefully it makes sense that he's not thinking about data that much. He's thinking about the systems where the data is going through, are they working on? Hopefully that answers your question.
Yes, thank you.
No problem. And
Sorry.
yeah, go ahead.
Yeah, can you talk about like a data structure and algorithm? I saw that Adam's like in several searches about data engineering, but is that like heavily used as a analytics engineer? Yeah, can you talk a little bit about that?
So you're talking about data structures?
Yeah, data structure and algorithm.
Okay, so that's a big keyword. Data structure and algorithm. Why is it a big word? Because there's a whole topic on it in software engineering, which is basically this keyword. So what are you thinking when you talk about it? Just to see that is there a part of it that you're talking about, or are you talking about the whole thing?
No, just like is this like very related to the concept of data engineering? Do we actually use it, and we use it to what kind of level?
Okay. So what is going to happen whenever we talk about data structure is, so as far as algorithms are concerned, algorithms is all about uh, it's about a lot of things, but the goal is to find a needle in a haystack. So if you want to search for something, search for something in a table, what is the fastest way to grab that piece is what algorithms would define. Data structure, on the other hand, is, so there are a lot of data types. So there is like there's a data type called JSON. There is a data type called, for example, simple strings. There is data types called number. There are data types that can change. There are data types that cannot change. And selecting the best data type to store things is what becomes a data structure problem. If the data type that I'm storing, is it going to perform as I need it to perform? So choosing that data type is basically where this comes in. Now, as an analytics engineer, do you care a lot about these things or not? The answer is not really. You don't care about these things because these things are very, very important on the sources level. And usually when things come to you, all those, so data structure piece is already figured out. Like, for example, they are going to give you a JSON structure because they are doing something. So the thing that you are coming is not selecting the JSON structure. JSON structure is selected for you. How will you get the best data out of it? How will you get out from that structure is what an analytics engineer would cover, but not selecting if this is the best way to store. So hopefully this makes sense that data structure is already determined for you when you're sitting on this level. As far as algorithms are concerned, when I talk about Snowflake, Snowflake has its own ways of optimizing things, which is happening in the background. As an analytics engineer, you don't design those algorithms because somebody sitting in Snowflake is designing them. But you need to understand how Snowflake is going through all that stuff just to make sure that your transformations can be done as fast as possible. So again, for algorithms, mostly you're thinking about what is the system going on behind, as well as like you can optimize your SQL queries as well. So that's another piece of algorithm. So I would say you are somewhat interested in it, and some pieces are already determined for you, but understanding them is important. So hopefully this answer your question. Does it?
Yep, thank you.
Okay. Now what happens? So data engineering. So basically data engineering starts from the loader, goes till the warehouse. Now there comes the BI layer. And BI is the business intelligence layer. You have created all the tables, you have cleaned the data. Now the data is ready to be analyzed. And in this layer comes the analyst. And if data, for example, data engineer sitting right here, so these are two different roles. There is a role called big data engineer or data engineer. This is something you're going to do in the next phase, or think about a lot more about this. And this extends a little bit more, which I'm going to discuss shortly, how this can go in here as well. But this part is basically, I would say, 10% business and 90% tech. This part I would say is 50% business and 50% tech. This part I would say is 90% business and 10% tech. So if you're coming from business fields, this might be the best entry point for you. And hopefully this 10% tech you can keep increasing and then jump into analytics engineering, which is 50-50. And then if you want to go more, you can jump to 50-90 or whichever way you want to go. Now, what these people are doing is basically grabbing the business meaning out of it, building dashboards. So there's a lot of dashboards happening here so that people can click and get their answers. Uh, a lot of tools comes here. So Metabase is a tool that sits here. Looker is a tool that sits here. Power BI is a tool that sits here. Tableau is a tool that sits here. And these are just dashboarding tools which are working on top of something that analytics engineer or data engineer work together to get out. And then you're basically trying to change that information into business decisions. So that's where analyst sits in. Now there is a whole piece for machine learning. And in that piece, basically that's where data scientists are sitting in. Is basically all the data that you get fed here. Machine learning, so data scientists then can use that data to run their machine learning models so that they can predict the future. So that's where they are sitting. So that's why usually when this data science thing started, people were hiring data scientists, and there's a story which says that these data scientists were not able to do the work because they used to give them this raw data. And the problem with the raw data is, as a data scientist, you know a lot of math, but getting it all organized might not be your best forte, because you are here to say, get my data ready, and then I can analyze it, because in order for the data machine learning purpose, we have to get data ready in a different way. But they might not be very, very happy doing these thing of moving data, make it scalable, or the part where data engineering and analytics engineering are sitting. They are more happy to give me the data ready, and I basically get my machine learning pipelines going. Big data engineers don't do transformation, trying to understand why their responsibilities stop in ETL workflow. So what is happening? There is something coming after it where I will talk about. So right now, these are called data engineers because these are specialized, like loading engineers, because they are writing these custom scripts. They are writing, like they are trying to make sure that these tools are running okay. Now, this part intersects a little bit with DevOps as well, but not much. But these are specialized people who are basically concentrating a lot more in these custom scripts. If these tools are not working, at least they can go ahead and write those things. The reason why I divide it, sometimes analytics engineer can cover this whole thing as well. And there's a big data engineering that is coming. That's a separate topic. Like once I get rid of all this, there is a separate topic coming where I talk about big data engineering part. But these people, I have seen these people to be big data engineers as well. That's why I just put it there. Uh, but there's a piece that's coming about them uh, as well. So hopefully, at least it makes sense what these three roles do, at least for now, and then I can go into big data engineering part. So hopefully, I can erase this. Okay. Okay. Now what's happening is the one route that we talk about was the source data goes into loaders, goes into uh, data warehouse, goes into BI. Now the problem that comes with data warehouse is that it's really good in what it does. Like it's there to analyze data. It's really good in it. Mostly the language that gets used here is SQL. But the problem is that it can only deal with structured data. And now there are some warehouses like Snowflake that started dealing with semi-structured data. And when I say structured data, this is something that can go into tables, like you can create a table out of it. Semi-structured data is like, it's not in tables. Like it's definitely not in tables, but it's more in this in a JSON form, like a semi, like you can kind of see the structure, but it's not easily changed into tables. So that's semi-structured data. And then comes unstructured data, which is like pictures. That is a data which, like, how can you analyze a picture? Because there's no way you can put it into a table. So there is that data. What happens when this was happening? There were two main problems with data warehouses. If your company end up there, machine learning models are quite slow to work on them. And the reason is machine learning models requires a lot of data. And when you are pulling that amount of data, the price of these data warehouses go way, way up. So it gets as you as you as your machine learning or data scientist organization matures, your use of data warehouse gets very, very terrible. Like you cannot really use them that much because it's going to cost a lot of money. The second piece of it is machine learning do depend on a lot of non-structured and semi-structured data. So you don't have, so that comes part of data structure part where you don't have a lot of support for these data structures that you need for machine learning. So something that started happening is this new architecture starts coming. And one more thing about this data warehouses is if you have streaming data, if you're putting data every 5 minutes, they get really expensive as well. They are really good for batch uh, data, but streaming data can get really expensive. Like when we try to stream data into Snowflake, it gets terribly expensive. On the other end, if we change that data into batch, uh, it's like 10% of the cost. Uh, so that's the problem. But in machine learning, like for example, if you have a machine learning model, sometimes you might have to train that model on a go. Like what that means is somebody give you a prompt and it goes in and you start thinking about that prompt and you're improving your model. Now that prompt is going to interact with that model and then spit out result, but you're training your model as things are coming in. So data warehouses are not the best structures to use there. What happens is you still use the loader, but you change this into data lake. And then it goes into machine learning. And what data lake is basically S3 that we learned is an example of a data lake. There are other data lakes out there. There, again, a lot of tools trying to solve that problem comes in. And what it is instead of loading things into a table, they keep it as an object. Like in S3 that you see is basically an object, where these machine learning models can come and grab these objects and make something out of it. Now, grabbing these objects means they can be unstructured, like pictures can be stored as well. They can be in a semi-structured form, uh, like a JSON object can be stored there as well. And these things are cheap. Like we talked about S3 bucket, and we're like, these are cheap. Like if this object you're not using, it can go into some other bucket, make it more cheaper. But it's definitely much more cheaper than the data warehouse piece. So, but the problem here is data warehouse, it's quite easy. It's very easy when you are sitting in data warehouse. Because everything is sitting in this huge table with Snowflake, for example, working behind using their algorithms to grab things faster. Here, we need a specialized system to grab things because now it's so open that we have to decide how that algorithm will look like that will try to grab things. Now, there are tools created to make that algorithm for you. And one of those tools is called Spark, which is really good in distributed computing. What that means is Spark, you can make a Spark script to analyze, and it will go at places. So it will grab all these objects, analyze it, and then give you results. But it can do it in a distributed fashion. It's not joining all these together, and only then the script goes in. The script can divide and conquer like this. So hopefully this makes sense that the script can go and do a lot of analysis, but here the main part is that you're not in that data warehouse structure. You are in a more open environment like S3, and you can analyze way more things. Now this part is still divided. Big data engineers basically work here because they are expert of Spark. That's something that's coming in phase 2. As well as you do see analytics engineering coming here. Like there is some analytics engineering here, but usually I would say 90% of the time, if the job gets posted as big data engineer, it's basically for this. Being good at this Spark, and then there are other things like Spark, but Spark is the most popular one right now. Now there are other tools that comes in that is helping to deal with this data lake, and that you need to know as a part of big data engineering, which you will go through in phase 2. Now, phase 3, what about Hadoop? So Spark is an improved form of Hadoop. So when you learn Spark, you will talk about Hadoop automatically. So those go together. Spark is just faster than Hadoop. But if there are still companies with Hadoop, but it's getting less and less popular, and people are taking Spark more and more. Okay, so that becomes the big data engineer part, and I'm just thinking in phase 3 now. The problem is this data lake is that it gets pretty disorganized because putting a file in S3 is very easy. You can just dump the file. Putting a file in Snowflake, it will ask you what table should it go to. It will try to push organization on you. Here, there's not much organization. So what happens, what used to happen, that files used to disappear. People didn't know what data is available because again, all these sources, there are so many sources here. And if we keep dumping their data here, it's really difficult to find, okay, which one is this data? Which one is this data? Or do I even have this data? Because it's like like it used to, the keyword that get used here was, it's a data swarm. Like it's like there's just so many things. It's very difficult to manage. In order to find a piece of data, you have to basically ask somebody who might have worked with the data, and then they can tell, oh, this is there. Yes, I have found it there. So they wanted to get more organization here. And then comes a product that's called Lakehouse. And the whole thing with lake houses is basically taking a lake and taking the house. So it's taking the organization of a warehouse and putting it on data lake. So I think that is also part of phase 3 that is coming in, is how to create these data lake houses. Uh, and then comes like Databricks have a product called Delta Table, which is a lake house. Uh, so all those new resources that tools come here. Uh, what else? So that should be okay. One more thing. So that is part of the infrastructure. One more thing that I wanted to discuss about BI, because there are multiple tools that are coming in that part too. And then my pen gave up again. Okay, let me refresh it. Okay, there's a keyword that's called reverse ETL that's thrown around as well. So what is happening as business are making decisions, business are like, for example, there's a customer, you get his data, and you're trying to think if I should call this customer again. So your problem is, should I call this customer again? And your sales team wants the answer for it because they want to call the customers that are most likely to buy products from you. But the problem is that you want to see if they are interacting with your website, if they are interacting with your mobile, if and sometimes if Facebook is telling you that this customer is watching your videos that you post on Facebook. But CRM is basically the system where these salespeople will be working on to understand, should I call this customer or not? So what's going to happen is all this data will be combined. It will go into your data warehouse, make a decision based on all this data. Should I call? So for example, the decision comes as yes, you have to put it back into the source so that when that salesperson open that customer, he can say, oh, okay, yeah, our whole decision intelligence that we did based on these other sources is telling me that yes, they are watching my Facebook ads. Yes, they did log in into my website. Yes, they did interact with my mobile. They are very likely to be my customer. They will become my customer very soon. So I better reach out to them. And this part of putting that data back into the source system is called reverse engineering. And you have like a lot of system like Census coming here, Light, I think it's called Light Touch coming here, tools which is just trying to do this stuff. So I think that's the keyword that comes there. So what I really want, so now where I want to go is basically this state of data engineering. And people keep on talking about tools, and this key gives you a little bit of perspective. So you can see ingest tools. So ingest tools, whenever I say these are the tools which are sitting as loaders. So these are helping us to load things into stuff. And you do see a lot of like, for example, ingest SAS tools. So these are SAS tools like Airbyte, Fivetran. That's what we are talking about. And all these tools, so in data, because there are so many tools, uh, it's really easy to get overwhelmed. So the way you deal with them is basically you go to that tool and try to see which category of the problem it's solving, and then as soon as you see ingestion, you automatically understand, okay, this is where it would be sitting. Uh, Ingestion tech, on the other hand, is those custom scripts. So if you have to write those custom scripts, these are the tools that are going to help you write it. Object storage is like that data lake part that we talked about. Uh, So these are so and that's where you see, I think Hadoop you see it, S3 you see it, and there are all tools, all the other tools that comes in there as well. Then comes metadata. So metadata is the part where you are basically trying to understand what your data is looking like. So as I talk to you about, like sometimes in these data lakes, and then metadata happens a lot more is happening in data warehouses as well, where you're trying to understand where all this data is coming from, and then you try to use these tools to understand basically where all this data is coming from. So these meta data tables are just helping us understand, okay, this is where the source, this data is started. This is how it got like it got cleaned, and this is where it's here. Now, these tools are not like, sometimes it's not that easy. You don't see how data is traveling, but these tools gives you enough points that you can try to solve that problem. Otherwise, if you have no way to understand that problem, uh, it becomes quite difficult to 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 solve it. So these tools are just collecting data about data, uh, so that people can understand how it's traveling, where it's coming from. And if you want to find certain table, it's really easy to search in here rather than going in Snowflake to search for those tables, because they are just keeping that data here. Distributed compute and analytics engine. So this is where data warehouses come in. So these are all the data warehouses that are out there. You can see Snowflake is there, Redshift is there, BigQuery is there. So these are the data warehouses that are out there. And these are the systems that are helping us run data lakes. So as I said, that there's an infrastructure that can go into these lakes. These lakes are very difficult to work on. Uh, so there is a distributed infrastructure that goes and analyzes that data, but it's not a platform. Uh, that's where this is coming in. Then we talked about orchestration, where we are like, okay, which transformation should happen first, which transformation should happen after? How can we decide that? All these tools are coming in there. Data observability and data quality, it's about checking, okay, before the transformation and after the transformation, is the data making sense? Is that exactly what I'm looking for? Uh, can I check this data before it gets presented to our end users in data? All these tools are coming here and trying to check and understand if the data is correct or not. And then comes ML. So I won't go into ML because I'm not I haven't done machine learning, but there are tools in ML that comes here. So those are all ML tools. So that would be something that data scientists would be really interested in. And then comes the data governance tool, which is trying to show you data, as well as it will make sure that if there is what type of data should be shared to what group. Like if somebody who's not allowed to see this data, is he watching it or not? Like trying to get all that permissions set up, making sure they are working correctly is basically where this governance piece comes in. So hopefully that gives you a little bit of perspective of, yes, there are a lot of tools, but they're trying to do the same thing. They are just offering you multiple ways of doing the same thing. If you understand the key concept, all these tools is just, yeah, you just have to uh, mostly Google search, read some of their documentation, and then you will get the whole idea of what they are trying to do. But watching these tools without these groups, I find it really difficult to see, because then it gets very overwhelming. But once you understand these small pieces, then it becomes really easy to understand these tools. So yeah, so any questions?
Is there some sort of map on this that kind of matches the role to the category? So the job role, for example, to ingest and data lake.
Yeah, so job category. So in terms of like who will be doing this?
Yeah, like who uses which section?
So yeah, okay. So some of these roles are like, yeah, it's not the best mapping, but I can tell you. So ingestion, you have data analytics engineering using it, because some companies ask analytics engineers to do that. You have big data engineers sitting here as well, but mostly these people are data engineers which are using it. Setting up this tool, DevOps is the one who are going to help you set this up, or infrastructure engineers are going to help you set it up. But as the data is moving in them, that's where data engineers come in. Uh, data lake, you can find data and analytics engineering role that are working on data lake, but usually when it comes to data lake, most of the roles are going towards big data engineering. So if you see a big data engineering role, and again, they are all part of data engineering. So that's the bigger group, and those segments come inside of it. They will be basically sitting in there. Metadata is basically used by everybody. So data analysts will use it as well. Infrastructure engineers are the one who set this up. So that's their role to set them up. But the usage of data is analysts will use it, data engineers will use it to understand where to find the data. Uh, Business users will use it. Uh, Data scientists would use it. So everybody is kind of looking at the data it's producing to understand what's happening. Compute engines, if I go to analytics engine, it's basically analytics engineer who mostly stay here. Compute engine, mostly big data engineers, but there are some analytics engineering sitting here, some big data engineering sitting here, but mostly, this is big data engineer, this is analytics engineer. Orchestration, I would say big data engineer works with it, analytics engineer works with it as well. So both are kind of here. Data quality, both are working on it. So they are both a part of this. This one, ML ops. So now with ML, there are two roles that comes in there. First role is machine learning engineer. And machine learning engineer will basically be sitting at, they do build a lot of feature stores. They will be thinking about observability and monitoring. So ML engineer comes in when they want to productionize a system. Like for example, there would be a lot of ML engineers working in ChatGPT so that their system can be served to general public. That's the goal of ML engineer. Data scientists are the people who are creating those systems. So they create those systems, but they are not productionizing it. They're not putting it to public. But all the models that are created, how are we analyzing those responses is made by data scientists. Machine learning engineers are just making it bigger so that everybody can use it. So that's where they both exist in here. So this is mostly ML. Now you see analytics workflow part. So analytics engineering and data engineer are helping them get the data ready. So there is this piece where analytics and big data engineer can come in as well. But mostly it works with ML, machine learning or data scientist. Governance, I would say governance piece is between infrastructure engineer or DevOps and the upper management, because upper management decide who can see what data. So your chief data officer will be interested a lot into this. But DevOps engineers or data infrastructure engineers are the one who are uh, helping us set this up. Uh, so hopefully some type of answer. Uh, Architect. So what is happening is data architects comes when you are thinking more about data products. So companies can have two agendas. Number one, they want to use data for themselves. So that's one agenda. But then some of these companies want to give this data out to public. For example, uh, Facebook. So Facebook get all the users' data from his website and then sell it to advertisers so that they know who are using their pages and all that stuff. So sometimes what you really need is you have to create something called data products, which you can present to general public and they can buy it. And that all data will be coming from your website or the tools that you have built to gather data. The data architect comes in two places. Number one, data architect is going to help you. If these are all the products that is out there, which product should you go with? Which products work with the use case that you have? Data architect is going to help you decide that, as well as he's going to help you build that data product as well. So architect would come in and said, okay, where is my data sitting at? So, uh, so architect is there to understand, like he can tell you what tools to use. So hopefully it makes sense that architect is like in order to create a house, architect is there to make a plan. Like he can tell you, okay, this type of wood you use, and all that stuff, but he cannot build that infrastructure for you. Data engineer would come in and build that infrastructure, or infrastructure engineer would come in and help build that infrastructure. A big data engineer would come in and help build that infrastructure. So hopefully it makes sense that architecture is there to understand what pieces I can join together, but he cannot implement things. But he can see the big picture and try to build those pieces, which pieces can go together to help this. Okay, any other questions? Okay. So yeah, so I am hoping that that gives you a little bit of idea, or if you have any confusion about what data engineering is trying to do, what all these other rules are trying to do, why are there so many tools? Do we have to learn all the tools? Like I'm hoping with this you answer all those questions, and like for example, hopefully you understand what rules sit where, as well as you don't need to learn all the tools. You just need to learn one tool in a certain category, and then learning the other tool is very easy. Like you still have to read the documentations, but you get the idea. Like once you learn one tool in this category, and that's what our goal is. Like for example, in analytics engineer, like we are using Snowflake. So we will teach you Snowflake, and then everything is very, very similar. They are just some are faster, some are slower, but uh, hopefully uh, all the tools would work. We will introduce you, for example, to grid expectation, and then everything here makes sense. We will show you. I think there's airflow coming uh, on phase 3. So then hopefully everything here makes sense. We are not doing ML. In object storage, we already talked about S3. So everything here makes sense. And then here we are using Airbyte. So hopefully everything here makes sense. Uh, and then we will using a lot of Spark. So we will be trying to pick up. I don't think so. We pick up anything from here because it's a little bit more infrastructure. But yeah, everywhere we are picking these tools up and helping you understand it. And this diagram is still one piece of it because I'm pretty sure the tools are way more. Like they come every single day, so this diagram is way bigger. But Anna, I am going to share this on our Slack group right now. So there you go. So that will give you access to that. Okay, so I guess that's all I have for today. So I'm going to just sit here until everybody is gone. If you have questions, you can ask now or you can ask later, but I'm here till everybody is gone. But other than that, lecture is done. Thank you very much for listening. And okay, sorry, there's a question. What are the typical deliverables for data engineer AE? So a broad deliverable is we have a data source. Can you bring that data source into these tables that you have already created? Like you have a sales table, you have a customer table, you have like all those business tables. Can you attach that source to the data so that uh, if there's a piece of information that we are missing, you can provide us with that, like so that that source can give us more information. And that deliverable is a broad deliverable. What it breaks into, can you create all the models that is needed to clean that data, to serve that data, make sure that whatever you build is scalable so that if that data becomes from 1 gigabytes to 50 terabytes, how are we going to control that data? Think about that stuff. Uh, Thinking about how to best write queries so that you don't spend a lot of money. Like the compute has to be as less as possible because everything is charged. Uh, so writing optimized queries. So basically, in that broad deliverable, those are some small deliverables that comes in. Hopefully that makes sense. No problem. Okay, yeah, you guys are good to go. If you have questions, you can stay. Thank you. See you on Saturday. Jing Hong, do you have a question? Okay, if you don't have a question, I can shut the session down. 3, 2, 1. Okay, thank you very much. Bye.